Well, so today I will start with the new topic, that is decision theory. Now, before I start the topic decision theory, let me go through the topics, subtopics that I would like to cover. So, starting with the first that we are going to study is the terms state of nature, event, decision alternative, and payoff. Then we will organize the data in the form of a payoff table or a decision tree. Next, we will find the expected payoff of a decision alternative, and then we'll go for opportunity loss table. We'll construct a opportunity loss table. After that, we'll come to the EVPI, the calculation of EVPI and the explanation of EVPI. EVPI is expected value of perfect information. Now, to start with decision theory, statistical decision theory. What is a decision? First of all, let us understand what is a decision. A decision we take whenever there are few alternatives. Suppose I want to travel from my home to office and I am having some paths, three alternative paths I am having, roads from say the home to office. Now, which path to follow so that the time taken is minimum? Now, we take decision in our real life every day, every now and then we take decision. So, what is a statistical decision theory? It is concerned with determining which decision from a set of possible decisions is optimal. Out of the alternatives given, we will choose the optimal one, which gives us the maximum profit, the decision which gives us the minimum time of travel. So that is called a statistical decision theory, and we apply the concept of probability. Now, to understand decision theory, it is very important that we understand what are the different terminologies, or so as to say, the components of decision making. The first component is the available choice in the layman's language, but if we call it in the decision theory language, it is called alternatives or acts. Alternatives or acts, that means what are the alternatives for the decision maker? Alternative can be two or more than two. It can be three, four, and so on. Now, the states of nature. The next terminology is states of nature. States of nature which are not under the control of the decision maker. It's a uncontrollable future events. So, state of nature is that element of decision theory which the decision maker cannot control of. Suppose from traveling from home to office, a traveler, office goer cannot control the traffic, or cannot control the rain. The rain may occur, which may cause further delay in travel. Right. So, and finally the payoff. So what is a payoff? Payoff is a needed for each combination of decision alternative and state of nature. So what is a payoff? Payoff means for a given alternative or for a given act and for a given state of nature, what is the profitability or what is the outcome, we can say. Just like suppose in the stock market, there are three stocks. So out of the three stocks, which stock the investor will choose so that the profit is maximum, given that there can be bullish condition or there can be bearish condition in the economy. How is the economy performing? Now, the performance of economy is not controlled by the investor. So it is a, so we calculate these three elements in our decisions. Number one, we calculate alternatives. Number two, we try to understand what is the states of nature or what are the states of nature. and for a given act and for a given state of nature, what is the payoff? Payoff may be in terms of profitability, outcome, it can be loss also. So we'll see later on. Now, so let us understand. So what is a payoff table? So a payoff table is a listing of all possible combinations of decision alternatives and states of nature. So a payoff table will consist of different alternatives. Suppose there are three states of nature and there are three acts. So there will be 9 payoffs. So it will be a 3 by 3 table. So 9 outcomes will come out if there are 3 act and 3 state of nature. Now there is a calculation. We calculate what is called expected monetary value, or it is also called expected payoff. What is expected payoff? It is the expected value for each decision. Now decision wise, just like if we go back to the stock market decision, the investor out of stock 1, stock 2, stock 3, which stock he will choose so that his return is maximum, the ROI is maximum. So this is called EMV, expected monetary value. So there is a formula we'll discuss in detail. Yeah. So EMV, this is the formula. EMVAI, this is equal to sigma PSJ into multiplied by VAI in comma SJ. So what is the meaning of this? First of all, let us understand this formula and then we will apply and will try to understand that how in decision making this formula is used. So EMV already we have discussed, it is the expected monetary value. That means what is the profit from the decision that we are taking, what is the profitability. So that we will get if we multiply the PSJ. PSJ is the probability of the jth state of nature. So what is the state of nature? Suppose state of nature may be two types in stock market, bullish and bearish. Suppose what is the probability that the market will be bullish? 60% is the chance that the market will be bullish. And suppose 40% is the chance that the market will be bearish. So P bullish, probability of bullish market is say 60% and probability of bearish market is 40%. So this is called a PSJ. This is the term PSJ. Next is VAISJ. V is first of all value. Value of the expected payoff when AI. Why we are calling AI? Because it can be I can be 1, 2, 3 depending on how many acts are there. And SJ, state of nature. Similarly, state of nature can be also two types of state of nature, 3 types of state of nature. So AISJ. So VAISJ, V within bracket AISJ, that means value of the cell where it is a combination of AI and SJ. Suppose A1, S1. That is called value when the act is A1 and value when the state of nature is S1. So that is called VAISJ. And EMVAI, already I have explained, it is the monetary value, expected monetary value for the decision alternative AI. So now to understand the topic in details, let us take a small example. So I have quoted a small example to understand this. So just I will go through quickly what is the problem all about. So again, it's a decision making under conditions of uncertainty. See, any decision is taken under uncertain condition, because the decision maker also does not know that what will happen in future. Future is uncertain. So we are basically trying to understand the decision making under uncertainty. Now this is a stock market example. So if you see the grid is, this is a payoff table. First of all, we need to understand this is a payoff table where there are three acts. What are the acts? Act is A1, A2, A3, which you can see in the vertical column. Okay, so A1, A2, A3. Now A1 we have defined as the purchase of Kaiser Chemical stocks. A2 as purchase of Ream Homes stocks, and A3 as purchase of Texas Electronic stocks. So there are three acts. If we see this total payoff table, so this is a 3/2 payoff table where the number of acts are 3, and the state of nature, there are two states of nature, bullish and bearish market. Now bullish market we have denoted by S1. These are some denotions. We can write probability of bullish market, that means P within bracket bull market or P within bracket bear market. But here we have given S1, S2. Bullish market we have denoted as S1. Bearish market we have denoted as S2. So now if we study the payoff table, so Kaiser Chemical, when the investor purchases Kaiser Chemical, then there are two conditions may happen. In case of bullish market, if the market in future is bullish, then what is going to happen is that he will get a return of $2,400. But if it is a bearish market, he will get a return of $1,000. So these are some of the acts. So next is Ream Homes. Now if Ream Home is this, if the purchaser buys Ream Homes, then in case of bullish market he will get a return of $2,200, and in case of bearish market he will get a return of $1,100. Texas Electronics, if he buys Texas Electronics, then he will get a return of $1,900, and he, in case of bullish market, in case of bearish market, he will get a return of $1,150. So this is in short. And another thing, we also, whenever there is an uncertainty, we should understand that there will be an element of probability. So as we know, probability we use when we are not certain. So in this case, we are not certain about the bullish or bearish market. So if you see the condition given in the small case, that according to this information, the probability of a market rise, that means bullish market, when market rise it is called bullish, when market decline it is called bearish. So in case of bullish market, the return will be 60%, the probability is 60%, and the probability of market decline is 40%. So these are all the information. So this is a payoff table under the conditions of decision making under uncertainty, where the payoffs are given in terms of dollar. So what are my, so it's a 3/2 matrix or payoff table matrix, where these are the values. So for what is A1 S1? A1 S1, whenever we call A1 S1, it is the first cell, that is $2,400. A1, so this is all the